This tutorial covers how to visualize 3D image data in Amira and Avizo. Adding new data to a project will automatically add an Ortho Slice display. This behavior is controlled by a setting in the Auto Display tab of the application preferences. You may disable or change the default automatic display if you want. To view these data with multiple cross-sections, add 2 additional Ortho Slices for a total of 3. For the second and third Ortho Slice, change the orientation setting to XZ and YZ respectively. Rotate the camera to view the data as you like. You can adjust the slice number for each Ortho Slice using the Properties window. Alternatively, change the 3D viewer to interactive mode. This allows you to click and drag each Ortho Slice display and change the slice number intuitively. For each Ortho Slice, you can adjust the lower and upper bounds of the color map to improve display contrast. For now, disable the display of these 3 Ortho Slices. Open the module browser again and attach a Slice module. This differs from Ortho Slice in that it can interpolate the data. If you enable the Rotate option, a trackball will appear within the 3D viewer. If you're in Interact mode, you can interact with this trackball and rotate the slice orientation. Even if you disable the rotation option, the slice will stay rotated. This can let you follow an oblique feature within the data. We will hide the display of the Slice module and continue to 3D displays. Once more, open the module browser and attach an Isosurface. This display will draw an enclosed volume for all regions brighter than some user-defined threshold. A histogram of intensities can help guide you. Use downsampling for large datasets for faster processing. Click the green Apply button to draw the isosurface. Here, I show the process with and without downsampling. Once computed, you can use the 3D viewer to zoom and pan the data. We will again hide the display of the Isosurface module to illustrate a direct 3D rendering. One more time, open the module browser and attach a volume rendering. You may need to adjust the color map lower and upper bounds as shown here. Any values below the lower bound are rendered transparently with this color map. You can choose a different color map using the Edit menu as shown here and selecting from the list. Color maps beginning with Vol-Ren are designed to work well with volume rendering displays. Further adjustments can be made in the separate volume rendering settings module. These are more advanced options for specific display requests. For example, you can change the shading style to a more classic volumetric look, an updated surface approach, or disable shading. Some users will prefer a rendering style with no interpolation, and others prefer a more smooth render. You can change that setting here. The material group of the settings is collapsed by default. Expanding this group shows more settings for the physically based rendering technique. Experimentation is encouraged when high quality is needed.